You finished with warm up? Charlotte, you started the warm up? Have you started?
These ones?
Yeah. You guys done with the warm up? The problem, Gary, you do this one too.
Well, I was thinking, if you're going to bring yours, how you gonna do the rest? Ready? Yeah, actually. Oh, I follow you. Yeah, so. It's not.
So some people finish the warm up and. You know. It depends what the. I love in terms of I like that. So. That's doing what works. So I think it's a word problem or something. It's the most.
The top one, do you probably split up?
Yeah. Okay. Let's go over this. Okay, just a reminder. And one of the reasons I'm reminding you is because I'm constantly reminded by administration is that there's to be no food or drink in the classroom, except for water. If honestly, if you have tea or something with a cap, I'm not going to say anything. If you have a cup of Coke, that's a problem. Okay, so please. And now, why are they clamping down on this? because they don't want problems with bugs and rats, which are attracted to sweet things and food and things like that. So even though I know that most of you are very, very considerate about cleaning up after yourself, there are those who aren't. And leaving crumbs or leaving messes is a problem. And even if you're very careful with your drink, you guys are kind of packed in, aren't you? So with a backpack could just knock over your drink. If it's water, it's just a pain. Anything else? It's gonna leave some sort of residue, which means they had to come and vacuum, not even vacuum, they had to wash the carpets. It's a pain, you know. So eat outside, please. And don't make me police you, please. Just go with the flow. So why am I hoping that this first problem is fairly straightforward for you? The first problem, the clock one? Because only two variables?
Yeah.
I'm hoping that you remember something like this from homework. So to do this, the concept we're dealing with is
Linear.
It was, oh,
the concept is
the,
arc length, isn't it? It's a distance along a circle, so that is by definition arc length. Are we talking about angular speed here? No, speed would be talking about a rate. If anything, we're moving towards a linear speed.
Rate is distance over time.
Rate is just distance over time. Well, linear speed is distance over time. Angular speed is angle over time. Okay, but we're just talking about arc length. So maybe you were paying attention last time and you remember that arc length is equal to r times theta. Do you remember this? Would this be a good way to do this problem? We have to convert. This is great if you have radians and you have theta. It's really nice. So radius and you have theta in radians specifically. But we don't have those things. So what's a good way? Yeah, what should we do? Make sure you have an idea.
you would put S equals, and then I put theta over like the total, which would be like 360, but in this case it's 60.
Ah,
Because it's a clock and the clock has 60 minutes. And then you would multiply it by pi or 2 pi r.
what do y'all think? Does this make sense to do it like this? Right, we don't have to think about it in terms of radians. We don't have to think about it in terms of degrees. We can think about it in terms of minutes. We know how many minutes are in an hour. Yeah, so we just fill in our theta, which is 25. We fill in our r, which is, I think, 5. Does this work out to be anything? 10 goes, I think 10 goes into 60, like 6 times. Is that right? Did I do that right?
5 over 12. 5 over 12.
Yeah, but then you can cancel out the 10.
So we get, is this what we end up with 25/6 pi? Okay, I don't care how you simplify, just make sure to simplify it. Now, the fact this is a word problem means I'm gonna want an answer that actually makes sense. Like decimal. Yeah, yeah, it's a little awkward to say that many inches, but did you get it? You use your
But if
calculator?
it's like this, could we say 25 over 6 pi, or would you want 13.5?
For a word problem, I want something that makes sense in the context of the problem, where it doesn't make the reader do more work. So like if you tell me that you're 5 pi years old, great, now I have to get a calculator, figure out your age. 5 pi years old, I guess you guys kind of are 5 pi, aren't you? A little bit more. Oh,
I know we're older.
older than 5 pi. Yeah, Justin, what did he get? Oh, just for the approximation. 13.08. Are we good with this?
5 times.
That
was
15.
That's 50.
Inches, of course. Any questions?
Wait,
Rachel, thank you for your help.
that should be-
Yeah, the calculator ready, and if you don't have a calculator, I definitely don't want you to do this by hand. That'd be crazy. But for word problem, generally this, and I would say round to nearest tenth or nearest hundredth or something like that. Now, if it doesn't give you any guidance about how to round, have I told you how to round? Three decimal places. So I didn't give you any guidance here, so 13.083. Okay. Inches. Okay. Yay. Was this difficult? The side opposite 130 degrees is 1/2, isn't it? Just like in the warm-up. Yeah, the short leg is half of the hypotenuse. And then we get this other side by taking the short side and multiplying that by √3, leaving us √3/2. Does anyone see where we're going with this? Yeah, it depends on your history here. Now this is 1. We know that the other two sides are before any numbers, we know that they are congruent, don't we? How do we know that? 45, 45, 90. It's an isosceles triangle for sure. And we know that to get these sides, we take that hypotenuse and divide it by √2. So these are both 1/√2, which is a fine answer, unless you want to rationalize, and you may or you may not. It's up to you. √2/2 is what that's equivalent to.
We must, does that mean like unless you tell us to rationalize, we can like.
Leave it. Yeah, you may leave the denominator irrational. Yeah, or no deduction at all. It's like freedom. And that's throughout the course. Unless it says rationalize the denominator, you are free to leave denominators with radicals. And I'm recording this lesson, so if you want to go back to it and say, wait a minute, you said it's okay. You have proof. This, just so you know, this is how we're being recorded. Oh. For your reference. Okay, let's go on to the packet. Today, what's going on here? I don't need that anymore. Okay, so SOHCAHTOA, does that word make sense to you? SOHCAHTOA? What language is that from? The trig language. Yes. Okay. Yeah. So SOHCAHTOA. Would you just check in with your neighbor, make sure that they know what that means? Okay. So first, S is sine, and then opposite over hypotenuse. It just tells you the relationships of sine, cosine, and tangent. Are those the only 3 trig ratios you know? Now we know that the reciprocal of sine is cosecant. Reciprocal of cosine, secant. Or the other one, reciprocal of tangent. Cotangent. Okay, draw the first quadrant. Oh, I drew it for you. With a circle radius r. Okay. Label an arbitrary point on the circle, XY, and make the triangle determined by the point. Okay, I'm going to put my point right here. Anywhere on that arc. And let's see, normally it would be something like this. P is coordinate X, comma, Y. I'm going to make a triangle there. Will this be a pretty good triangle to make? No, I need to use the coordinates, right? I'm going to go down to the X axis, and then I have this here, and I'm going to use the radius, which we know the radius of this circle is R, as it says, the radius is. So I have a triangle here. Is that a right triangle? Yeah, I'm using the coordinates. So the bottom side is X, the tall side or the vertical side is Y. I was just asking for you to write, let's see. Oh, label the angle in standard position as theta. Okay, so right here, is that standard position? Yeah, yeah.
Well,
Right,
yeah,
it goes from here to the angle. And all your image looks similar. And you can put your point here or here, but the ratios will all be the same. So go ahead and write the 6 trig ratios based on this triangle. Make sure your neighbor is doing okay.
Yeah. No, that's- Oh, Cody.
Okay. What should I start with? Is it okay if I do this?
L,
Yes,
so,
no.
sign of what?
Oh, sorry, not.
Or yeah, whatever. We need something in there. If you're missing something, I'm going to be taking out points at least once. So sine theta equals y over r. And how do I know it's y over r? Opposite of hypotenuse. That's a so of SOHCAHTOA. Cosine of theta is equal to x over r tangent theta, y over x, easy. I like to make 2 different columns. The next column is going to start with cosecant because I'm no longer going to look at the triangle. I'm going to look at sine. So r over y, secant of theta, r over x. I do that right? I guess the better question is, did you do it right? And if not, make sure that you adjust them appropriately. Okay. Unit circle. By definition, the unit circle is a circle radius 1. So whereas I could have marked an R right here and right here because those are all radii, aren't they? Radius, 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 anywhere from the center to a point on the circle. Here, this is a 1, this is a 1. It's asking you to label all the points on the arc whose coordinates, degrees, and radians you remember. In other words, I expect you to know that right here is both 0 degrees, 0 radians, and the coordinates are,
1, 0.
is it 1, 0?
Yeah.
Are we sure it's 1, 0?
Yeah.
Yeah, it's unit circle. 1, 0. Unit circle. This is the origin. This point here is 0 degrees, 0 radians,
Yeah.
0, 0. Let's see how many other points on that arc you can label.
Oh, spend.
Yeah, that's what you took.
I'll give you another 15 seconds. I'll go over this. And if you're already familiar with this, I'm sorry, I'm gonna go a little bit slowly here just to make sure to go over this thoroughly. Okay, so in terms of points on this circle, now I'm just working the first quadrant. I need everyone's attention up here. And look at this point. The point here is, of course, 0, 1. Yes?
Yeah.
Now, in terms of degrees, it is 90 degrees. We're talking about standard going from here to here. That's definitely 90 degrees. Radians. How do you know it's pi over 2?
Radius pi.
Yeah, if you think from here to here is 180, or here to here is pi, that would make sense that this is just half of pi, pi over 2. Okay, the next one I'm gonna do here is right in the middle, of course. I'm gonna label this because I need an angle here, don't I? Imagine that's directly in the middle, which means I've cut that 90 degrees in half and made it 45 degrees. Now I'm gonna start putting these in here just because, well, I guess it's gonna get a little crowded, won't it? I'll leave it on the outside. That should go there though. So I'll keep this consistent. 45 degrees are in radians. It is pi over 4. Now, some people say the coordinates here are 1, 1. What do you think about that?
No.
Yeah, that's you can understand why someone might think that in the beginning, but it's definitely not 1, 1. I need to make a triangle here. Do I know anything about this triangle here? It is 45, 45, 90. And we also know that the radius, or in this case, the hypotenuse is 1. And how do we know it's 1? There's a unit circle. The radius is 1 everywhere. So how am I going to get the other sides?
Divide by root 2.
We already did in the warm-up. Each side is 1 divided by root 2, or very commonly written root 2 over 2, comma root 2 over 2. Pretty essential to know that point right there. Should I cut it in half again?
No.
I'm going to take the original 90 degrees and break it up into thirds. So that's why this is going to go like here and here, maybe something like that. Just, I think I missed the first one. I think it's a little too, I'm going to make it a little nicer. So this first one is degrees, 30 degrees. We broke it into thirds. And this other one is 60 degrees. I hope that makes sense. 30, 60, 90, all the way up. In terms of radians, it is pi over 6. And then do we know the sides of that triangle? Do we know the x and the y? Yeah, we know it. Root 3 over 2, comma 1/2. The other triangle that we have here?
It's the inverse.
Yeah, it's the same triangle. We just flipped these. So 60 degrees radians, it's pi over 3, and then 1/2, comma root 3 over 2. And this is all the essential information you need from the unit circle. If you are unclear about any of this, please make sure to iron it out until you are perfectly clear about where it all comes from and what it means. Whose responsibility is it to make sure that that happens?
Ours.
Yes. It's my responsibility to make sure you handle it eventually. But it's your responsibility to make sure that you're doing it in time as we go. Well, look at this. Complete the unit circle, coordinates, degrees, and radians, which means everything we just did in the first quadrant, you're doing the second, third, and fourth quadrant as well. And it's a little bit small, I apologize for that.
Do we have to draw any,
Yes, please.
really?
Yeah. Let's see an old friend right now. See the circle.
Still close. I'm doing the bottom.
No, night. So when you're done or stuck with the unit circle, check with your neighbor. You and your neighbor are thoroughly confused, maybe get some help from people around you.
It is the why.
That's a great question. We'll talk about that after we do this. Okay, so ready or not. Go ahead and take a look up here. I'm not gonna fill all this in, I'm gonna fill in some of it. But the fact that this is pi, so let me, put one more red piece in here. These red pieces break the circle up into exactly 12 pieces. Do you see that? 6 pieces on top, 6 pieces on the bottom. So when I start with a pi, I hope it makes sense that I'm gonna label this first one pi over 6, yes? Then as I go around, I'm just gonna count. This is pi over 6. And just look at this, put your pencils down for a minute. I just wanna make sure everyone's clear on this. This is 1 pi over 6, this is 2 pi over 6, this is 3 pi over 6, this is 4 pi over 6, 5 pi over 6, and this is really 6 pi over 6, isn't it? Does that make sense? And hopefully you're left a little bit uncomfortable with the fact that I didn't simplify some of the fractions. I do expect you to simplify, but I just want to show you that it's just counting going all around. And I go past 6 pi over 6 to 7 pi over 6, 8 pi over 6, etc., etc. If I were to just count this, I know this is a lot going on here, and I apologize for those of you who already know. These green ones have now broken the circle into 8 bits, 4 on top, 4 on the bottom. So the first one is pi over 4, because the top is split into 4 portions, and I'm just going to count those increments along. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And you can see the overlap makes perfect sense. I hope 5 pi over 4, etc. This is thinking in radians as we go around the circle. I just want to talk about the coordinates and degrees at one point. I think I'll do 5 pi over 6. 5 pi over 6. The coordinates there are, and we know that those are the coordinates because it's the same triangle as we had on the other side, right? This was root 3 over 2, comma 1/2. The other side is negative root 3 over 2, comma 1/2. And the degrees, of course, are 150 degrees. And we know that, yeah, 30 from 180, that's what I would do. Are we good with that? With that, I expect you to be able to do the rest. I'm not going to have it here. I want to go back to example 6 and add something to it, just like we did in example 5. Let's do sine theta, cosine theta. Well, not theta. Let's do
30.
well, let's do theta. Just anyone. Sine of theta. And I'm going to put just a random triangle in here. Here's a random triangle. So here's theta. I'll call this P, comma X, oh, P, which is X, comma Y. According to this, sine of theta is Y over 1. Cosine is X over 1, or just X, and tangent is Y over X, which is essential, isn't it? This is why we use the unit circle, because anytime we look at the X coordinate, we know we're looking at the cosine of that angle. When we look at the Y coordinate, we're looking at the sine of that angle. So we keep that in mind as you do this grid. Sine of 30, you're just looking right here.
I want to just 1, 20, 20. Yeah.
Unit circle quizzes, daily unit circle quizzes. Yeah.
So actually, no, actually. We did that last year, we all did it.
Yeah.
Okay,
I want proof.
you haven't. I'm sure you think I'll find it.
I have proof that you.
Oh,
wait, no. That file got deleted. Oh,
You remember, please.
no,
You definitely.
no. Jerry, I don't remember that.
No, it's fine.
Stephanie,
Are you done?
wait.
It's too early. Yeah, take some time. Take some time. And again, check it with your neighbor. Your neighbor might be struggling with the first three while you're on the last row. That's not good.
First X. The all. It's not very first.
It's 5 or 6.
So there are three.
5 or 6. I said 5 or 4.
All right, negative 25, 5%. Negative 5.
3, 5, 4, 4, 5, 5.
Yeah.
The even stuff. I should
Operate.
Oh, I get it.
Right.
So 7.
5 or 4, 2 power 4.
Every 4. Because I'm going 45 degrees. I'm gonna see 45.
Oh, y over
Does that
x.
make sense?
Yeah, so for like 5 or 6.
Yes.
On the cosine, um,
3, 5 or 6. You can't skip it.
That's 75 over
it's over R, so.
Negative R.
Exactly.
Wait, no.
Bingo.
No, secant. Cosecant. Oh, this is because that's fine. What is it? One side.
This is 5 or 6. This is 2 power. This is.
I'll ask for 4 people. Answers for 4 people. Just one row at a time. I don't want to call on 16. That seems like.
You can accept this. You can do the father.
Oh, yeah. Yeah, I should have had them ready today.
No. No.
Next time for sure. Next time for sure.
Or not.
So the secant.
I just want it today.
Secant is the opposite.
I see.
No, I derived it from mind of.
Cosine.
You're.
I mean, cosine.
Oh, you never know. Okay, hold on. It's just.
It's-
Hold on, then I guess.
Yeah, exactly, but if you raise your hand,
Yeah.
then you know.
Stop, show cosine.
Don't.
Cosine is fine.
Yeah, I know. That's exciting. No.
No,
It's not.
that keeps you on your toes.
I'm on.
You don't need to be on your toes. You're already up here.
Right.
No, I'm glad.
Yeah. So it sounds like.
You're already. I know.
It's just,
Yeah.
cosine, so you just, would you like the numerator?
The numerator.
Okay, so like, for this one, it would be like root 3 over 1, which is just root 3 because if you like multiply root 3, if you divided this by this, it becomes that. And those case laws, which is-
Is it,
The Y value.
it's, -1/2, the.
Yeah.
Multiplied over x.
Who needs more time?
-1/2 over.
Then the
Well,
negative 1 over 0.
Minus 30.
And we'll go over these in 1 minute. I'll just take volunteers for this one. I'm not gonna call it.
And then 1/2 over.
Not yet, in 1 minute. Let's see how.
This.
One over.
That's your.
Oh, wait, tangents.
Yeah.
Irrational. Yeah, irrational is opposite or.
Yeah, it's y over.
Yeah, I got 2 on the funds.
You're gonna funny this together.
You sure?
So it is your set. I don't think it's negative.
Oh, yeah.
So-
I was like,
Wait.
That's it.
There are a lot of options.
That's it.
3 over 2.
I keep forgetting it's -1.
Oh, I just,
Because.
this private two.
Are we all ready? Ready or not? Let's see what you got.
Yeah, it's.
Aaron, you have a question? Can you give me the first four, please?
Yeah.
Top row.
We're gonna go 1/2,
This
one,
is the y divided by 1 by 2.
negative root 3 over 2 undefined.
Negative root 3 over 2, you said?
Yeah. Undefined.
Oh, good question.
Okay, do we agree with these? Let me just examine like that undefined for that negative pi. Can you please point in the negative pi over 2 direction, everyone? Okay, so we look at the coordinates are 0, -1. Remember, the tangent is just
Y over X.
y over x. So yeah, anything with 0 in denominator, undefined. That pi over 4, please point in the direction of pi over 4. Pi over 4 right here, where the coordinates are the same. Anything over itself is equal to 1. Nicely done. Thank you, Baron. Seems like you're ready for the Unicircle quiz. The next row, who'd like to give us the values there? If you're interested, just put your hand in the pi over 2 position. You like that one? No?
Oh.
Yeah, Josephine, yeah, follow directions.
Yeah, is it 2, -1 over root 2, 1/3, and -2?
And what was the last one?
-2.
-2. Thank you. Good. I don't know. Are these correct? I'm a little bit afraid of one of them.
I am afraid.
Wait, is it 10? So,
Yeah, I'm a little bit afraid of that tan 750.
isn't it 1 over root 3?
One of root 3 is that what
Oh,
it should
yeah,
be?
that's what I meant to say.
Oh, okay.
Wait, really? Wait, can we go through all of these?
Yeah.
Sure, yeah. Yeah, let's do all these.
The first one's
I
fine.
got.
5 pi over 3, would you please point in the direction of 5 pi over 3? I don't know, here's a 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, yes, did I do that right? So I'm looking over
Yeah.
here, is that it?
Yeah.
That's 5 pi over 3. So all I need to know is the coordinates specifically of the cosine, is that right? Secant?
It's like, and then
You
you.
take my 1/2, flip it, oh, it should be negative?
Wait, what? No.
No, it's a x coordinate, which is positive right there, so.
So it should be,
the 1/2.
that one's.
So this is good.
Yeah,
so
so the second, that one,
315, of course. is-
on the other hand,
A
because
little
it's
bit
a
more.
45, so it's gonna have some root two.
It's sine, well, if there is a root two, it's not. Yeah. It is right.
Negative root.
Yeah, it's not the same thing. Yeah, what we were using was a root two over two, but it is negative because we're dealing with sine, so that's a y coordinate. So either that or
Oh,
this.
that's the thing.
Do I care which one you use?
Oh,
No, just don't put negative in the denominator. Which I'm sure you didn't. 750, is that even an angle?
yes.
Yeah, that's the same as
30.
30 degrees, so we just look in that place where I can see right now, and we look at the
Y over X.
y over x. So it's either 1 over root 3 or if you really don't like seeing those radicals and denominators.
Wait, but it's Y over X, so 1/2. Over, and then times 2 over root 3, the two's answer.
Perfect, yeah. So 1 over root
Y
3.
X over.
Yes, perfect. You did the cotangent. I see, okay. I understand, I like cotangent too. But everything can't be cotangent. 2 pi over 3, would you please point in that direction? Right there? I got 1 pi over 3, 3 pi over 3. So 2 pi over 3, I can't see it there, but you can see it on yours, so we're just looking here at the x or the y coordinate? Y coordinate, the y coordinate, and then flip it.
Yeah.
Oh, yeah, it is the second. At reverse and at negative 2. Okay. Is it making sense? A little bit?
Wait, no, negative. It's not negative.
It's not negative 2?
The Y coordinate is negative
Oh,
root 3.
we're here. 2 pi over 3, so it's negative 1/2 comma root 3 over 2.
Right. and the
Oh,
Y coordinate
close
flip
secant. Oh,
is 2 over root 3 or 2 root 3 over 3.
oops. Just checking to see if we're paying attention. I see how it is. Is that right? 2 over root 3?
Yeah, but
Thank you. Either that or 2 root 3 over 3. If you'd like to attempt these 4 problems, please put your hand up in the pi over 3 direction. Someone who hasn't gone yet, please. Yes, thank you, Sage.
Root 3, 0, negative root 2 over 2 and undefined.
Wait, my hand is too slow. Root 3, was it positive or negative 0?
Negative.
Just kidding. Okay, so the root 3, 0,
Negative 1 over root 2.
There.
And then undefined.
undefined. Okay. Do we agree?
all of I mean.
I want to see the negative 225. It's negative 225. Please point in that direction. Yeah, right up there. Okay, so then we're just taking, since it's cosine, all you're doing is taking the x coordinate. And remember, I like to think it's just alphabetical, cosine and the sine. Thank you, Sage. If you'd like to do this next one, put your hand up in the 5 pi over 9 direction.
Over 9?
5 pi over 9.
Oh, it's like, yeah, it's like.
It's just in your head, divide 0 to pi in 9 parts. 5 pi over 9 is going to be over here. Okay, so yeah, so it would be like this. So who'd like to do? Last 4? Someone who hasn't gone yet? Yes. Tell me your name, Ronan? Okay, Ronan.
Undefined. Yeah. Negative 1/2. Undefined. 2 over.
What is it?
2 over.
2 over root 3. I want to check one of the undefineds because we've only done one of them. And then I'll get your question. Or Julie, do you have an issue? Oh, it should be 0. Yeah, that's one I was going to check. So let's see. 3 pi over 2 is
Down.
down. Okay, so we're looking for secant. We're looking at the
Uh,
cosine coordinate. So I really can't see it now.
Right.
But 0, negative 1, and 0.
Well,
Reciprocal of 0. What is reciprocal of 0?
it's one defined.
Yeah.
Zero over one, the opposite is one over zero, that doesn't work.
Yeah, zero is the same thing as 0 over 1, so the reciprocal of that is 1 over 0, which is undefined. Yeah, the reciprocal of 0 is not 0. Oh, 0 is undefined. Thank you, Ronan, that was great. I hope that this has made sense. I'm not gonna bug you any more this period except to say, please start on your assignment.
It's online.
Yeah, it's always on mine now.